Hello everyone. So in this video, we are going to see how we get active and reactive power in case of AC system. Okay. So we'll be analyzing these things from very basic concepts, and we will also analyze what is the main reason to get reactive power in case of AC system. Okay. For that, I have considered a RL circuit. Okay. So this is my RL circuit. It is operating in steady state. There is no AC transients and all. So for simplicity, I have assumed my source voltage as root 2 V cos omega t, and the current is root 2 I cosine of omega t minus theta. Because theta is the lagging angle, since it is RL circuits, so definitely my current I of t will lag the voltage by some angle of theta. Okay, and this V and I are the RMS values basically. Now, if I draw the phasor diagram of this voltage and currents, so let's say this is my voltage phasor, my current phasor will be here, and this is my angle theta. Now, this current and basically this V and I are the RMS quantities. Okay. Now, this current has two component. One component will be along the voltage phasor. So this will be I of cos theta, I cos theta, and there will be one more component which is 90-degree lagging of the voltage, that is I uh, sin theta. Okay, so these are the two quantities. You can resolve your current I into two quantities. Basically, we will prove these things like the component of current that is in phase with the voltage are basically responsible for the active power, and the current which is in 90 degree from the voltage phasor, that is this one I sin theta, it is basically responsible for the reactive power generations. Okay, now I want to write the active and reactive component of the current I. Basically the current that is in phase with the voltage, that is sometimes we call it as the active component of the current. So I can write it as active component of current I of t. It has some RMS value, so I cos theta is its RMS value. So maximum value root 2, and if I write the equations, cos of omega t, right? So this is my equation 1, and it is the active component. Because why? Because this particular term I cos theta, it is in phase with the voltage, that's why it will be active. Now there is a reactive component also, that is 90 degree from the voltage phasor, so that is root 2 I sin theta cos of omega t minus 90 degree, because it is 90 degree lagging, right? This particular thing, this phasor is lagging 90 degree, so you can resolve it root 2 I sin theta sine of omega t. So this is my equation number 2. Now I want to calculate the instantaneous power because of active component of current. I also want to calculate the instantaneous power because of the reactive component of the current. Okay, now let's proceed for that calculation. Now let's say I want to calculate the active component because of active component. So P of t is equals to uh, V of t into IA of t. Okay, so here I have root 2 V cos of omega t into root 2 I cos theta uh, cos omega t. Okay, so you will get 2 Vi cos theta cos square omega t. So you will get Vi cos theta 2 cos square omega t. If you resolve this particular quantity, you will get Vi cos theta 1 plus cos 2 omega t. Okay, so and if you see the average value here from here, let's say this is your PA of t. If you take the average of the particular equations, you will get the average value. See, this is the alternating quantity, so it has average value as 0. I'm just considering average value, so this is my 0. So my average value, so P will be Vi cos theta. So this is my active power. and this active power I am getting because of the this particular current I cos theta. It is in phase with the voltage. So the conclusion is, if you have any circuit that has some current and it has a component of current which is in phase with the voltage, then only you will get the active power in case of AC. Now consider the capacitive and the purely capacitive and purely inductive circuit. If you consider purely inductive circuit, say let's say you have this inductor, you have this voltage, and you have this current. So you have this voltage phasor and you have this current phasor. Okay, they are 90 degree from each other. So if you see the component of the current that is in phase with the voltage, it is basically zero. It is I cos 90. It is zero. So there will not be any active power. Okay, there will only be a reactive power. Now come to the reactive come to the calculation of instantaneous power because of reactive component of the in the current. P R of t root 2 V cos omega t root 2 I sin theta sin omega t. You will get Vi sin theta to sin omega t cos omega t. Okay, so Vi sin theta sin 2 omega t. Okay, so here this particular term is basically it's called reactive power. If you take average of this particular equations, you'll get this average value sin 2 omega t. Its average value is simply 0 and its peak value is Vi sin theta. So this peak value of this oscillating waveforms and all are basically called reactive power, and it keeps jumping flowing from source to load to source, like that it will be flowing, and that this is something we call it as a reactive power. Okay, so now it is proven that the component of current which is 90 degree from the voltage, that will give the reactive power, and the component of current which is in phase with the voltage, that will give the active power. So this is the main concept behind active and reactive power generations. And we in power systems we do several kind of study to compensate this reactive powers and all. Basically reactive power is something that are very essential to control it, and we have to manage this reactive power flow in efficient ways and all. We will be studying, maybe I'll bring some lecture based on like how to compensate the reactive power, how the reactive power, if there is excess amount of reactive power that load is demanding, then your voltage regulation will be poor, you will be having more line losses, and many phenomena are there. I'll be discussing all of these things later, but I hope in this video it is clear that what is active and reactive power and the generations, how they are coming basically. Thank you. If you have any doubt, you can ask me in comment section. Thank you.